So this should be a fun video lecture, because what we're going to do is some more incident response, and specifically your task is going to be able to create a forensics image over a network connection. You may not have physical access or immediate physical access to a computer, and so the only way you would be able to make a forensics copy is either get on a plane, buy some large hard drives or a NAS, and physically go to the place where the physical computer is located. And that may mean flying somewhere, and actually that's not a bad idea if you want to make a lot of money, but that can be hard on you and your family. The other way to do this is to create a physical copy over a network connection. So that's what we're going to be doing here. And we're assuming that we've got a physical computer with a Windows operating system running on it. And then back at the lab, we've got our Linux-based storage device where we're going to copy the the physical copy to. The second part of this will be to use some tools called the Sleuthkit, which is a free and open source toolkit that you can download and install very simply within Linux to do very simple physical examination. But the big part of this is to be able to make the copy over a network connection. So we want to make a forensics copy over a network connection. And this is a very simple task, and we're assuming that we have a Windows workstation somewhere physically dislocated from where we're actually living now. And so we'll probably need the help of somebody there at the other end to assist us, or we could assume that it was in a lab upstairs or downstairs, and then you could go do all this yourself. As I mentioned in the beginning, one of the ways you can create the copy is through well, actually I didn't mention this, but let me just mention this now, is that there's a very, very expensive commercial software that will assist you in doing this, such as Encase Enterprise, or you can do this with Linux. And you can either spend $10, $20, $50,000 for a tool, or you can learn to do this with Linux all by yourself. So you be the judge of what you'd like to do. So how are we going to do this? Well, the best way to do this, well, first thing we need to do is to consider whether we need to capture any running network processes in the Windows XP machine, whether we need to capture RAM or anything that's dynamic. And so in this instance, let's just say we don't need to do that. We'll talk about that later. But let's say we do need that physical copy of the disk, which means that the first thing we need to do is that we need to shut down our copy of Windows, which I've done here. And of course I'm showing you all of this through VMware. So we have a copy of XP here, and what we need to do is we need to boot this with a bootable copy of Linux. And so for this demonstration, as you see here, I've got a bootable Linux CD that I've connected with my virtual CD within VMware Workstation. And then what we can do is a couple of other things just to make this a small assignment, and I really want you to consider this, is if you do have a copy of Windows XP or something small, is that you can install this within your VMware Workstation. And notice what I have here is I have two hard disks. I have one that's 40 gigabyte, which is my main hard drive. I've also created a second hard drive that's just 256 megabytes. So what we're going to do is we're going to be working with this 256 megabytes because we want something small. The whole idea is to make sure that you've got the procedures correct, not the fact that we're doing something that looks realistic. And even 40 gigabytes wouldn't be realistic. We're probably talking about a terabyte or at least 500 gigabytes for a hard drive. So what I want you to do is, and I'm not going to tell you how to do this, you need to figure this out on your own, because that's part of this course is learning to learn things. But let me tell you, it's not tremendously difficult. is to create a second hard drive, and you do that through the VMware settings, and then you attach this, and you need to format it, and you're going to need to copy some files there. And I'll in your project I will explain in more detail what I would like, but for right now just follow along. And in fact, if you just want to do this and set up two Linux virtual boxes, you can do that in Linux, but I would suggest that you create a small secondary hard drive and attach that to your virtual machine so that this will go fairly quickly and won't eat up all the space on your Forensics hard drive. So that's what we've got here, and I've made sure that I've got my Ubuntu bootable CD in here. If you're doing this with a physical computer, you're going to have to make sure that this boots first, that is the CD boots first. Otherwise, if the hard drive is set to boot first in the BIOS, then that's going to boot up. So you'll need to get into the BIOS, and how you do that depends on the type of computer, but you can Google for that information. Usually there's some key that allows you to access the BIOS. And some it's F2, and other computers, I think Dell is F12. And so if we're doing this virtually, the way to do this is to power on into the BIOS to make sure that the CD boots up first. We get into our virtual BIOS, and we gain focus, so we can go over, and it says the CD-ROM is set to boot first, followed by removal devices, and then the hard drive. And so we're good there. We can exit. We can discard the changes since it's already set to that. And so if you're doing this from a distance, you're in Boston and you're working with somebody in San Francisco, you're going to have to walk them through the steps to put the Linux bootable CD into the CD drive, and then make sure that in the BIOS it's selected to boot up with the CD, and walk them through the commands, but it's fairly simple. And while we're doing that, on the other side we have whatever our Linux box is over here. There was one thing that I didn't do, and that's to make sure these are on the same network. So let's see what network these are on. This is on the 10.130 network, and we can go back over here and let's look at the settings for Windows and see what it says. We're on VMnet 5, so it's probably not going to be on the same network. So that's on a host-only network. Let's go over here and see what this one is on. We can always change this. That's NATed. Okay, let's go and make sure they're on the same network. You can use NAT for both or Bridge for both. Just need to make sure they're on the same subnet. And usually notice that the network manager catches the fact that it's changed the subnetting. Okay, so let's see what network we're on. 192.168.14.134. Let's write that down. So we're back over here to our Ubuntu CD that is running on the XP clone here. And we can go up, and for some reason the mouse does not work that well in certain versions of Ubuntu that's running, so we can use our keyboard to select the different menu options. And so this is .14.130. So we're good. Let's see, go back over here and we'll see if we can ping this machine. .130, and we can ping it. Okay, so we're all set up. Is to look at the partition information on the XP machine. You notice that it's got dev SDA is the 40 gigabyte hard drive, then the 256 megabyte hard drive is STB. Notice they each has a single partition, so we want to make sure we grab that partition. Notice this says NTFS over here. So we know what type of partition it is when we go to mount this for a logical view. And so we're going to be using two tools to capture this information. The first is called DD, which is disk dump, which should appear in any Linux or Unix that you run across. And what it does is it reads and writes bytes, usually from the physical device. The second tool we're going to use is called Netcat, which is called the Swiss Army knife of Unix utilities, and it just reads and writes streams of bytes, and it's good for moving information over a network. If you're a Linux administrator, you need to make sure that the access controls on Netcat are set to owner only, which should be root, because this can be used to open a port as a backdoor on a Linux box. So the first thing we need to do is we need to set up the forensic station so it's listening for the network connection for all the streams of bytes we're going to be sending to it. So we can use, and I don't believe that on this device that Netcat it's set up for read-write for everybody. We won't worry about that now. And so we can type Netcat, and we want to listen on port 8888, and we want to redirect the contents of that to a file called winxp.dd. And notice that I'm not hitting enter yet. Let's just go back over here, and we will since we're needing to access the physical device, we need to use sudo. So we'll use dd for disk dump, and the input file is dev sdb1. And now what we want to do is to pipe that to Netcat. And we want to pipe it to the IP address 192.168.14.130. .130 is the current machine, to port 8888. And we need to wait 3 so that it makes sure that it finishes reading and writing. Don't hit enter yet. Go back over here, make sure that's correct. We can hit enter. Now I want to go back and change one thing over here. That's going to use the standard block size of 512, so it's going to be a little slower. So what we'll do is we'll increase the block size to 8192. If you have a fast network, that should have no problem sending the network packets over in those block sizes. And so now we can hit enter, making sure over here, notice that it's listening. It doesn't give you any feedback, but that's Unix. Let's hit enter. This should go fairly quickly. And sometimes if you want to know what's going on, for example, you can see how much has been copied over, and we're almost done here. If you do a really large hard drive, this is going to take a long time. That's when you go out to lunch. And it hasn't changed, so notice that the process is stopped. If we go back over to our XP clone, it says that it copied over this many records. If we multiply 32638 by 8192, we should have the size of the hard drive in 24 seconds at 11 megabytes a second. I did this previously and it was much slower than this. So it's good to bump up the block size. Another thing we want to do is we want to capture the MD5 sum of SDB1 to make sure that it matches the copy that we sent over. And so again, we can use Netcat to listen, and we can output that to an MD5 file. Now let's go ahead and hit enter. Doesn't hurt anything. And back over here, we need to type sudo md5 sum dev sdb1 and pipe that to Netcat to the listening machine. Should go fairly quickly. Let's go back over here. Is it still listening? Let's look at the MD5. And there's our MD5 of SDB1. What's the last thing we need to do is that we need to calculate the copy of the MD5 sum to make sure that it was a good copy, a perfect copy. So we can type MD5 sum of the winxp.dd and concatenate that. Make sure you do that to the MD5 file. And let's cat the MD5 file, and we have a good copy. Okay, so the next thing we want to do is to do a quick analysis. So let's take a look at that DD file. Let's see what kind of file it is. Whoops, I've already got a file on here. Let's do a file winxp. See what that looks like. So OEM ID NTFS, media descriptor F8, it's a hard drive, heads and sectors, and so on. So now let's go about mounting this, and I've got a directory called winxp that we're going to mount it on. So sudo mount -t, we're going to just say auto and see if that does it, see if it can guess that it's an NTFS sector, partition rather. And we need the -o for options. We want to make sure we don't change this, so we can use the RO for read-only. And since this is not a physical device, but it is a file, we can say that we want to mount it on the loopback device. We can now give it the name winxp.dd and the name of the directory. Let's see if that works. And apparently it works. How do we know? We can type mount. We see winxp is mounted on the loopback device, read only, no SUID, no dev. Those are the defaults on here. So now we can go to the winxp directory and take a look at the logical files. So notice that we have one file called homework.txt, and we have 3 directories down here: more stuff, system volume information, and so on. So what that allows us to do is to look at the logically allocated files. Recall though, if there's anything deleted or anything in slack space, it will not show up on here because we're looking at a logical analysis, not a physical analysis. So if we want to do a physical analysis, we'll need to use the sleuthkit, which is a tool that I talk about in the next lecture. So that ends this lecture on how to make a forensics copy over a network. You will find this very useful. You should carry around in your backpack at least 1, if not 2, Linux bootable CDs, because they do come in very handy.